In this video, I'm going to show you how I created this Eye of Agamotto. This project has been the most complex mechanical prop build I have ever done. My goal with this project was to improve upon my previous attempt at creating a functional Eye of Agamotto prop. About 3 years ago, I created my first eye prop and released it to the public. A month or two after I released my project, another maker by the name of EZBSVS released one which was objectively cooler. It had more moving parts and was much closer to the correct scale. With the new Doctor Strange movie coming out and con season fast approaching, I found myself interested in revisiting this project. The mechanical design of this project was a doozy. I'm not super proud of this CAD model, and I had to pull out a lot of less than ideal tricks to get it working. I'm not going to go too deep into my modeling techniques here because they're honestly trashed here. I stared at a GIF of the eye opening for hours while applying some brain to a spreadsheet to calculate the gear ratios necessary to get the motion I wanted. I then used a custom gear generator in Fusion 360 to generate all of the custom gear ratios needed to get the movement I needed. Essentially, there is a central gear that all of the other bits that have to move tap power from. For various engineering reasons, this is a better approach than what I did before. I went through 2 major revisions of the design and a dozen of minor tweaks before reaching the final design. One design feature I did very intentionally from the beginning was separate mechanical parts from painted aesthetic parts. Mechanisms often need a little bit of oil or sanding to get working properly, and this is the antithesis of a paint job. Separating the parts means you can get the mechanism to work independently of the carefully painted parts. For the electronics, one of my main goals was to keep it simple and avoid code and microcontrollers. For this project, we just need to drive a motor forwards and backwards with end stops and to light up an LED. This is easily accomplished with a simple schematic. I'll put the bill of materials for electronics in the description, but the main players are a 9-volt battery, a few SPDT switches, a gear motor, wires, and an LED. I've designed it so you can drive the motor in each direction and it automatically stops at the correct location. It should be a relatively beginner-friendly electrical project. Make sure your print is in good working order and easy to turn before expecting this tiny motor really to do anything. Alternatively, you can skip the electronics entirely and just have a hand-operated Eye of Agamotto. It's extremely satisfying to spin. For the paint job, most of the aesthetic components are separate from the mechanism, meaning they can be processed separately. For this project, we used a standard process for metallic effects. The name of the game is Smooth and Shiny Undercoat. To accomplish this, we printed all of the parts with our SLA printer using a hard resin. You could get away with an FDM if needed, but the surface finish for an SLA print is much better than FDM. So this really cuts down on the amount of filing and sanding necessary. Once the SLA prints were cured and the supports were removed, we started with a coat of Vallejo surface primer. Once that was dry, we went for a coat of all-clad gloss black. This preps the surface for the metallic paints and is really crucial to getting a metallic-like effect. Once the parts were dry, the gold parts were hit with all-clad's polished brass, and the silver parts were done with Spastic's mirror chrome paints through our airbrush. You can see we rubbed a lot of the metallic paint off trying to get this particular one working for this video. So we definitely recommend finishing the outer housing last after you've got yours working. You could also achieve this metallic effect with a gloss black spray paint base and a metallic spray paint if you don't have an airbrush. The assembly on this is pretty easy, but is relatively involved. I'll create a separate video walkthrough taking it step by step. Essentially, there is a main plate that everything mounts to. Another improvement I tried to make over the previous version was simplifying the parts. This version uses the same screw and shafts everywhere so you could mix and match. My previous version had 3 different lengths of shaft and 2 different screw lengths. I did my best to pick tolerances that are reasonable, but forgiving. All of these parts were done with our stock Prusa Mini with no sanding. I designed the mechanism to be easy to debug. I would highly recommend assembling it 1 ring at a time and really checking the gear mating of each stage of the mechanism. It's surprising how much force a little booger on a gear tooth can add, and it's really hard to pinpoint where it is if the whole thing is fully assembled. Often, there is a bit of a break-in period. Moving the mechanism by hand back and forth a few dozen times usually loosens it up. This project was an absolute bear, but I am super happy with the results. Comparing this version with the previous version really highlights the size difference. In the coming days, I'll get to work on a printable stand, since I assume most people will want to display this on a shelf. I also plan on making Etsy kits available very soon. I'll update the description as those become available. I played with the idea of designing a circuit board for the electrical side of things. Let me know in the comments if that's something that interests you. If enough people are interested, I'll make that a kit as well. As always, thank you for watching. Hopefully, I've earned your subscription and would appreciate a like and a share. I'll see you next time.